Iran has spent decades building one of the most dangerous missile programs on the planet. Not by copying others. Not by buying from the highest bidder. But by studying, reverse engineering, and rebuilding from scratch, under some of the heaviest sanctions in modern history. What came out of that pressure is a weapons program that now keeps military planners in Washington, Tel Aviv, and Riyadh up at night. This is not about politics. This is about the hardware. The actual missiles, the actual drones, the actual numbers, and why each one matters. We start with ballistic missiles. Shahab-3. This is the missile that changed everything for Iran. Built on older Soviet technology but heavily upgraded over the years. It carries a warhead of around 760 kilograms and can reach targets up to 1,300 kilometers away. That range puts Israel, Saudi Arabia, and U.S. bases across the region well within reach. Iran produced several hundred of these. It was the first missile that forced the world to take Iran's program seriously. Getter 110. Think of this as a smarter, longer Shahab-3. The warhead separates from the body during flight, which makes it harder to shoot down. Range sits around 1,800 kilometers. The nose cone was redesigned to come down faster and more accurately. A few dozen are believed to be active. It took everything the Shahab-3 did and made it more dangerous. Iran's first missile that can actually steer itself after re-entering the atmosphere. Range around 1,700 kilometers. A few dozen are believed operational. The ability to change direction on the way down means air defense systems have a much harder time predicting where exactly it will land. That single feature makes it far more threatening than anything that came before it. Schedule. This one runs on solid fuel. That matters because liquid fuel missiles need hours of preparation before launch. The schedule can be ready to fire in minutes. Range is around 2,500 kilometers. Stockpiles are estimated between 25 to 50 units. Speed of launch means very little warning time for the target. That rapid readiness is the whole point. Khorramshahr-1. Heavy, slow, and devastating. Liquid-fueled with a range around 2,000 kilometers and a warhead pushing past 1,800 kilograms. That is one of the heaviest conventional warheads on any Iranian missile. Around 50 are believed to be operational. It was not built for speed or stealth. It was built to cause maximum destruction on impact. Khorramshahr-2. The follow-up pushed the range past 2,000 kilometers and added better guidance. A few dozen are estimated active. More accurate than the original, which means it can be aimed at specific infrastructure rather than just a general area. Refinement over raw power is what defines this version. Hypersonic missiles plus advanced ballistic systems. Most missiles fly in a predictable arc launch, go up, come down. Air defense systems are built around that exact pattern. Iran looked at that and decided to break the pattern entirely. That is where hypersonic missiles come in. Fateh-1. This is Iran's first hypersonic missile and one of the most talked about weapons in its entire arsenal. It travels at speeds between Mach 13 and Mach 15. To put that simply, it covers the distance from Tehran to Tel Aviv in under 4 minutes. Range sits around 1,400 kilometers. A few dozen are believed to be in service. What makes it genuinely dangerous is not just the speed. It can change direction mid-flight. Current air defense systems in the region were not built to chase something moving that fast while also turning. Fateh-2. The upgraded version does everything the Fateh-1 does but adds a hypersonic glide vehicle on top. After the missile reaches high altitude, a glide vehicle detaches and schemes through the upper atmosphere at speeds above Mach 15. It does not follow a normal flight path, so tracking it becomes extremely difficult. Range is estimated near 1,500 kilometers. Production numbers are still unclear, but it is considered an early deployment weapon. It represents the cutting edge of what Iran has publicly shown the world. Haj-Qasim. Named after a well-known Iranian general. Solid-fueled, range around 1,400 kilometers, and it carries a precision seeker in the nose that guides it toward the target in the final moments of flight. Between 25 to 50 are estimated to be active. The combination of solid fuel for quick launch, long range, and a precision seeker in one package makes it one of the more complete weapons in the program. Desful. Extended range version of an older design. Reach goes out to around 1,000 kilometers. Upgraded warhead and better accuracy in the final approach. Likely under 50 units are in service. Built to hit well-protected targets like air bases and radar installations that sit deep inside defended territory. Khaibar-Shikan. The name means fortress breaker. Solid-fueled with a range of 1,450 kilometers. Weighs significantly less than older designs, which means it can be moved and launched faster. Around 50 operational units are estimated. In the final moments before impact it maneuvers, which is the part that gives modern air defense systems the most trouble. Iran used this missile in a live strike in 2024, confirming it is not just a display weapon. Rod 500. Built using carbon fiber instead of older heavy materials. That choice cuts the weight in half compared to older short-range missiles while still covering 500 kilometers. Numbers are limited, likely under 30. The lighter body means it can be launched from smaller, more easily hidden vehicles. Harder to find before launch is half the battle. Fateh 110. Short range, solid fuel, simple to operate. 300 kilometers range with a 450 kilograms warhead. Iran holds several hundred of these, making it by far the most widely produced missile in the program. Fast to launch, reliable and cheap enough to export. Iran has sent these to multiple proxy groups across the region. The sheer number in the stockpile is what makes it significant. Fateh 313. Direct evolution of the Fateh 110. Same warhead size, but the body is made from newer composite materials that push the range out to 500 kilometers. A few dozen are active. Every upgrade in this series follows the same logic. Take what works, make it go farther without adding weight. Zulfiqar. 700 kilometers range with an electro-optical seeker for precision targeting. Iran actually fired this missile during a real strike on targets in Syria. That combat record matters because it means the system has been tested outside of a training environment and performed. Around 50 to 100 are believed to be in service. The drone program. Missiles are expensive. A single ballistic missile can cost anywhere from a few $100,000 to several $1 million. Iran figured out a long time ago that drones could do a similar job for a fraction of the price. What followed was one of the most aggressive drone development programs outside of the United States and China. Shahed 136. This is the drone that got the world's attention. A loitering munition, which means it flies to a target area, circles, and then dives into whatever it was sent to destroy. Range of 2,500 kilometers, warhead of 50 kilograms. Cost per unit is under $20,000. Iran has produced these in the thousands. Hundreds were transferred to Russia and used extensively in Ukraine. When launched in large numbers together, they become extremely difficult and expensive to stop. Shooting down a $20,000 drone with a missile that costs $2 million is not a sustainable defense. Shahed 131. Smaller and cheaper than the 136. Range drops to 900 kilometers and the warhead shrinks to 15 kilograms, but the production cost goes down even further. Thousands are believed to be in service. When mixed with the Shahed 136 in the same swarm attack, the two different sizes and speeds force air defense systems to split their attention across multiple threat types at the same time. Shahed 129. This is Iran's main combat drone for longer missions. 24 hours of flight time, range near 1,700 kilometers, and it carries 4 precision-guided weapons. Over 100 are estimated to be in service. It was reverse-engineered from captured American drone technology. Iran did not just study the design. They rebuilt it, adapted it, and put it into regular operation. Shahed 149 Gaza. Large, high-altitude, long-endurance. Carries up to 13 weapons at one time, making it comparable to the American MQ-9 Reaper in terms of payload. Operational numbers are limited, likely under 20. Its significance is not in current numbers but in what it represents. Iran can now build and operate a drone in the same class as the most capable strike drones the United States flies. Shahed 171 Simorgh. Built by studying a captured American RQ-170 Sentinel stealth drone. Flying wing design, low radar cross-section, built to penetrate defended airspace without being detected. Fewer than 10 are believed operational. The number is not the point. The fact that Iran looked at one of America's most advanced reconnaissance aircraft and rebuilt their own version from scratch is the point. Shahed 191. Compact jet-powered stealthy. Range around 450 kilometers and small enough to launch from a truck. Low dozens are believed to be in service. Speed and a reduced radar signature give it a tactical strike role that slower propeller drones simply cannot fill against defended military targets. Rush 2. Purpose-built to hunt radar systems. Range estimated near 2,000 kilometers. It homes in on the signal a radar emits and follows that signal straight to the source. Dozens are believed operational. Its existence means that any country operating radar systems near Iran has to think carefully about leaving those systems switched on during a conflict. Care. Turbojet powered with a top speed near 900 km per hour and a range of around 1,000 km. A few dozen are in service. The speed alone separates it from most Iranian drones. It bridges the gap between slow loitering drones and actual fighter aircraft, capable of both strike and interception roles depending on how it is configured. Mohajer 6. Dual-role drone that carries smart bombs and can take off from short unprepared runways. Range of 200 kilometers. Iran operates dozens and has exported this one widely across the region. Its combination of low-cost, real weapons capability, and ease of operation has made it one of the more commercially successful items in the entire defense program. Fotros. One of the largest drones in the fleet. Over 30 hours of flight endurance, ceiling above 7,600 meters, and a range near 2,000 kilometers, fewer than 20 are believed operational. It can carry multiple missiles at the same time, making it function as a long-range strike platform that can stay on target for extended periods without needing to return to base. Cruise missiles and anti-ship missiles. Ballistic missiles fly high and come down fast. Drones are slow and cheap. Cruise missiles are different from both. They fly low, hug the ground, follow the terrain, and stay under radar coverage for most of their flight. That combination of low altitude and long range is exactly what makes them difficult to stop before they reach their target. SOMAR. Iran's longest-range cruise missile. Built by studying Soviet Kh-55 technology. Flies at low altitude across distances up to 2,500 kilometers. Numbers are limited, believed under 50. A missile flying that low for that long is genuinely hard to track on conventional radar because the radar needs line of sight and the ground gets in the way. That terrain-hugging flight profile is the entire advantage. Haviza. Evolved from the SOMAR with a declared range of 1,350 kilometers. Designed to fly deep into defended territory at low altitude and strike fixed targets like air bases, power plants, and command centers. Production numbers sit in the dozens. Where the SOMAR was a starting point, the Haviza is a refined operational weapon that Iran has publicly test-fired multiple times. PAVA. Containerized cruise missile with a range around 1,650 kilometers. The launcher is built inside what looks exactly like a standard shipping container. It can be placed on a truck, a train, or a cargo ship, and no one looking at it from the outside would know what is inside. Estimated at a few dozen units. Finding and destroying these before launch is genuinely difficult because they look identical to millions of shipping containers moving around the world every single day. Abu Mahdi. Anti-ship cruise missile with a range of 1,000 kilometers and the ability to adjust its course mid-flight to avoid incoming interceptors. Numbers are limited but growing. A 1,000 kilometers range forces any naval force operating in the region to stay extremely far from Iranian coastline if they want to stay outside its reach. Most of the Persian Gulf and Gulf of Oman falls well inside that engagement zone. Qadir. Sea and land-launched anti-ship missile with a range around 300 kilometers and an upgraded radar seeker for finding and tracking ships. Iran operates several dozen. Built specifically to target naval vessels operating inside or passing through the Persian Gulf. The waterway is narrow enough that almost any ship transiting it would come within range at some point during the passage. Locally produced version of a Chinese anti-ship missile. Range around 170 kilometers. Iran operates between 100 and 200 across both land platforms and naval vessels. This one has a combat record. It was used against Israeli ships in 2006 and performed as intended. That real-world use matters because it separates a weapon that works in practice from one that only works on paper. Nasser 1. Small enough to mount on a fast patrol boat. Range of 35 kilometers. Iran operates hundreds of these across its coastal force. Flying just above the water surface, it turns even the smallest patrol vessel into something that can threaten a warship. The Persian Gulf is full of these small boats, and every single one carrying a Nasser becomes a problem that a larger navy has to account for. Khalij Fars. Anti-ship ballistic missile with a range of 300 kilometers. It does not cruise at low altitude like the others. It goes up and comes straight down onto the target at speeds above Mach 3. That steep diving attack from above is a fundamentally different threat profile compared to a cruise missile coming in horizontally. Close-in weapon systems on warships are designed to handle horizontal threats. A near vertical high-speed impact from above is a much harder problem to solve. Hormuz 1. Anti-radiation missile with a range around 300 kilometers. It does not aim at a ship or a building. It homes in on the signal coming out of a radar system and follows that signal directly to the source. Numbers are believed to be limited. Its purpose during a conflict is straightforward. Force the opposing side to shut down their radar or watch it get destroyed. Either outcome benefits Iran. Hormuz 2. Same airframe as the Hormuz 1 but with an active seeker added for targeting moving ships at ranges up to 300 kilometers. A single launcher can now be configured to hunt either radar systems on land or naval vessels at sea depending on what is needed. That flexibility in one platform reduces the number of different systems needed to cover multiple threat types. By this point you have seen the missiles. You have seen the drones. You have seen the cruise missiles and the anti-ship weapons. But individual weapons on a list do not tell the complete story. What matters is how all of it fits together and what Iran can actually do with it. The range problem. Most of the weapons covered in this video can reach anywhere between 300 kilometers and 2,500 kilometers. Draw a circle from Tehran with a 2,000 kilometers radius and you cover Israel, Saudi Arabia, every U.S. military base in the Gulf, large parts of Eastern Europe, and significant portions of Central Asia. That is not an accident. Every range upgrade across every missile family in this program was a deliberate choice to expand that circle year after year. The numbers problem. Iran does not have one type of ballistic missile. It has over a dozen active variants. It does not have one drone. It has over 20 different platforms at various stages of production and deployment. Any defense system trying to stop an Iranian strike has to deal with hypersonic missiles, slow-loitering drones, low-flying cruise missiles, and anti-ship weapons all potentially arriving at the same time from different directions. Defending against one type of threat is hard enough. Defending against all of them simultaneously is a completely different challenge. The cost problem. A Shahed 136 costs under $20,000. A single interceptor missile used to shoot it down can cost over $1 million. Iran understands this math perfectly. Flooding a defense system with cheap drones forces it to burn through expensive interceptors. Once those interceptors run low, the more dangerous and precise missiles become significantly easier to get through. This is not a new idea, but Iran has built an entire production industry around executing it at scale. The sanctions problem. Every single weapon in this video was developed under heavy international sanctions. No foreign components. No outside technical support. What that tells you is that 4 decades of isolation did not slow this program down. It pushed Iran to build domestic manufacturing, domestic engineering, and domestic supply chains for weapons development. At this point, sanctions alone are not going to stop what has already been built and is already in service. What it all means. Iran is not a country with a few missiles sitting in a warehouse. It is a country with a fully developed, multi-layer strike capability built over decades of deliberate engineering work. Whether that capability is ever used at full scale depends on decisions made in rooms far removed from the weapons themselves. But the capability exists. It is real.